Lesson 5, the constant acceleration equations. These, today, after today, you will have the 4 main equations that we're going to be flogging for the bulk of the rest of the year, and honestly, for the first third of Physics 12. You don't have to memorize these equations. You'll memorize 2 of them because you're lazy. You're naturally lazy, and you get tired of looking them up. The reason I had you get your yellow formula sheet out is one of the things I want to teach you to do, or train you to do, Jacob, is when we're looking for an equation, teaching your eyes to glance in the right location, which may not sound like much, but I'm telling you on a test, if it can save you 1 second because you know your eyes have remembered where to glance, that helps. That adds up. Here's a specific example. I give you a graph here. What are we graphing on the y-axis? What's the letter V stand for? I got to be fussy. It's not velocity this time. Read the title and you'll see why. It's speed, and you'll see why in a second, Cole. What are we graphing on the x-axis? Time. So here is a graph showing the uniform acceleration of an object. And in fact, Cole, what we did is we dropped it off of a cliff. And that's why I graphed speed, because technically if you drop it off of a cliff, which way do things fall? Down. Downwards, do we call that positive or negative? I didn't want to graph something below the y-axis, so I'll say, graph speed. And we'll do that quite often, in free fall in particular, because sometimes it's easier to think that when you're falling, you're speeding up, even though technically you're getting more and more negative, and more negative is actually a smaller number on the number line. Yeah, we'll look at the scale. A asks, hey, what's the acceleration of the object? How can I find the acceleration from a speed or velocity time graph? Where does it show up? What? Slope. You know what? Let's go rise over run. And they were nice enough to draw the triangle for me. So I'm going to go right there, right there. Hey, what's my rise? Do the math. Count, or maybe subtract. 8. 10 minus 2, 8, yes? Slope, which is rise over run. It's going to be 8, and I'll even include the units, divided by. And what's the run? The run goes over to here, starts here. What's my run? 0.8? What is the slope? 10. And if I wanted to get fussy, I would say the units were meters per second, or meters per second squared. It's the acceleration. B says, write an equation for the graph. So we're going to write something like this. Y equals mx plus b, except I'm not going to use y. Y is a dumb variable in this case. Look at my y-axis. What would be a clever variable to use on the y-axis that would match the variable that I wrote on the y-axis, do you think? Let's go v equals. That's a good call. What did the letter m stand for? The slope. What was the slope? 10. I'm not going to write x. What would be a more clever variable to pick than x based on this particular graph? That's units. I said variable. T plus, and b was the y-intercept. What is the y-intercept of this graph here? 2. There's an equation. Velocity equals 10t plus 2. What I'm going to do now is I'm going to see if I can use this specific example to generalize this. I'll show you what I mean. I think I can write this as velocity equals, you told me 10 was the slope, but what did the slope mean on a velocity or speed versus time graph? What was that 10? And if your hint is, look at the units. What was that 10? What did it mean? Acceleration. Plus. And what does that 2 mean? What would you call that? If I said, tell me what it means in real life, you would say, oh, that means that at time 0, what? what do we, time 0, the velocity is 2 meters a second. What do we call the velocity at time 0? We've given it a special name. I heard it. What? Or we could call it V0, I'll call it VI. And Cole, by saying that, I think you've also allowed us to figure out this V, the front V, which velocity must that be if it's not the initial? Which one are we actually finding here? Yeah. This is your first big equation, except traditionally we don't write it this way. Traditionally we write it as V final equals, we write the V initial first plus AT. And it works for vectors, even though we got it from the scalar equation, from speed. Trust me, it works for vectors. And I believe that is on your sheet about 1/3 of the way down. I actually, Jake, snuck this one in earlier. Don't write this down, but 2 days ago I gave you this. This is the same equation. It is? Yeah, I'll prove it to you. What is this letter T doing mathematically if it's sitting on the bottom of a fraction? What mathematical operation is that T doing? It's dividing. If I wanted to move it over then, how would I move it to this side? What's the opposite of dividing by T? So you're saying that if I wanted to rewrite this, I could multiply the T over here? I could. Oh, and if I wanted to get the VF by itself, how would I move the VI over? What's in front of the VI? A minus? So how would I move the VI over? So you're saying VF equals VI plus AT. It is the same equation in disguise. Race, one of the things I'm going to start you off on today is what we call formula manipulation. I'm going to start teaching you the art of being able to rearrange an equation, hopefully in your head. If you are willing to learn that, even if you're shaky at math, trust me, it's worth learning it. It cuts down on your memorization an awful lot. You see, this equation here that we've just written down has 4 variables in it, VF, VI, A, and T. It's actually 4 equations in one. Doug, you can memorize all 4 equations. You can, or you can learn to just rewrite them in your head very easily and way cut down on memorization. Now, Cliff, it's going to be out of your comfort zone for a little bit, because I'm going to be challenging you to do some algebra in your head. Trust me, it'll work. I've done this for years, and I have yet to have a student not think I've showed them one of the best shortcuts on earth. Oh, who's in chemistry here? It's a great shortcut for chem as well, because it'll let you rearrange chem equations in your head. Next page over. So, what we've just gleaned from this graph is this. V final equals V initial plus AT. That's the scalar equation. That's final speed equals initial speed plus acceleration times time. Cole, I can also vectorize it. Why didn't I put a arrow over the T? T's a scalar. It's not already a vector. It's never a vector. It's a scalar. Time does not have a direction. Well, I saw this sci-fi movie once where they went back into... No, we're staying in the regular physics world. Some of the Star Trek physics is good, but not all of it. Okay? That's equation number 1. Let's see if we can generate equation number 2. To find the displacement or the distance the object travels, we can't use this from Science 10 because in Science 10 you dealt with a constant velocity, which is boring. However, last day we did say that the average speed is displacement over time. We said that 2 days ago when you were doing that little map measuring with your ruler and you had all this funky roads. When I said find the average velocity, you were going displacement over time. I can rearrange this equation to get the letter D by itself. How? What's the T doing to the D mathematically? Adding, subtracting, multiplying, or dividing? Dividing, so how would I move the T over? I think I can say this. Displacement equals average velocity times time. We're not going to stop there. We're not going to stop there. Let's suppose that Taylor has $10. and let's suppose that coal has 20 bucks. What do the average between them? How can you get the number 15 from a 10 and a 20? Mathematically, what can you do?
Add them and divide by the amount of the.
Keep it even simpler.
Okay.
Add them up and divide by 2. If you're finding the average between two things, add them up and divide by 2. If you want to find the average of something, add them up and divide by 2. Do I have V average right there in my formula? Then another way to write this would be, my pen. Add them up and divide by 2 times t. Have you got that equation somewhere on the yellow sheet? You do, but I wrote it slightly differently. See if you can spot it. Instead of dividing by 2, I chose to multiply by something in front instead. Can you see it? What? Okay, you know what? Let's clue in. We're in the big world now. Dividing by 2 is the same as multiplying by a half. And in fact, on my calculator, I don't multiply by a half. I don't type a 1 over a 2. On my calculator, I multiply by, what's the decimal equivalent of a half? 0.5. Okay? But you see where it is? That's big equation number 2. Next page. What we're trying to do today, Maddie, is move from graphs. Graphs are great. Graphs are visual, and our brains are great at spotting visual patterns. When I showed you this first graph here, all of you clued in, it keeps going like that. Where if I'd given that to you as a list of points, it would have been much tougher for you to figure out what was going on. Problem with graphs is they're pain. You need graph paper. You need a ruler. They take a lot of work. We want to move away from graphs today and see if we can get there algebraically with equations. That's our goal. So we're going to do a chart to convince us that this equation that we just derived works. And then we're going to say we're not doing a chart anymore. Because charts are another way to spot a pattern. That's too much work, Chris. But we'll do one. So here's what we have. We have an object starting at rest. You know what? I would underline the word at rest. That's important. And at 0.0, it's starting in the bottom left-hand corner of a graph, if I want to think about it that way. It accelerates at positive 2 meters per second squared. And I wrote in brackets, positive means to the right. Fill in the chart below, blah, blah, blah. Okay. At time 0, what's our initial velocity? What does the question say? What did we underline? So 0. Doug, what's our acceleration according to this question? So after 1 second, if I start at 0, how fast am I traveling after 1 second? How fast am I traveling after 2 seconds? 4. How fast am I traveling after 3 seconds? 6. Now we're going to get a bit clever. We're going to find the average velocity. And remember, average velocity means add them up and divide by 2. And the first thing it wants us to find is the average velocity between 0 and 1 second. Okay. How fast was I traveling at 0 seconds? Trick question. 0 plus. How fast was I traveling at 1 second? Divided by 2. What was my average velocity over that section of the trip? 1 meter per second. Let's write that in right here. Over the first second, I averaged 1 meter per second. I was going slower sometimes, I was going faster sometimes, but you know what? My average speed? 1. What's my average speed over the first 2 seconds? Well, it's going to be almost the same thing, except it's still going to be starting out with an initial speed of 0. But what's my speed after 2 seconds? What's V final? 4. What was my average speed? 2. Over the first 2 seconds, I averaged 2 meters per second. Is the next one 3, Mr.? I don't know. Let's find out. What's my average speed over the first 3 seconds? Well, that's going to be from time 0 to time 3. How fast was I traveling after 3 seconds? 6. My average speed was 3 meters per second. So we use this. Mr. Dewick, you wrote in the work before V initial plus V final divided by 2. Here you wrote final plus initial divided by 2. When I'm adding, does the order matter? 3 plus 2 is the same as 2 plus 3. I get sloppy. Now let's use displacement. Now displacement is the average times time, is where we started out. And then what we did, Brad, is we rewrote this displacement equation to get this messy one here. Let's see if this messy one here works by using this. So if I want the displacement from 0, it's going to be the average velocity. What was the average velocity? 1 times time. 1 second. How far from starting was I after 1 second? 1 meter. How far was I from where I started after 2 seconds? Well, that's going to be the average velocity, which was 2, times the amount of time I've been traveling for, times the time interval. How far is the time between 0 and 2 seconds? How far from where I started from am I after 2 seconds? 4 meters. Oh, how far, Doug, was I after 1 second? 1 meter. How far after 2 seconds? How far did I travel between 1 second and 2 seconds? How many meters? Can you see it? How many? 3. See it? Lots of information in there, actually. How far did I travel after 3 seconds? Well, that's going to be average speed, which was 3 times the time, which is also 3. How far did I travel after 3 seconds? 9 meters. How far did I travel in the 3rd second? See it? Abraham. You said it. How far did I travel? Loud. 5 meters. Lots of information in there. But I think what I'm finding is this equation works, yes? But I would much prefer, rather than going through this lengthy chart, I'm going to say, since we got this equation here from it, let's use that and just plug and chug. Okay? Oh, let's do a graph to convince us that this graph works. You guys really like that plug and chug? Really? Okay. I thought I'd used that before. No. That's my expression for get your calculator out and just start typing carefully. We call it plugging and chugging, right? So here's a graph. This first graph, we're graphing position versus time. By the way, what number is right here? How many hash marks are there on the y-axis? Count. What's each hash mark worth? Okay, just make a note. We're going up by 2s. On the x-axis, we're going up by 1s. I know that we started out at 0, 0. After 1 second, I've turned the page. You guys have to read your chart. After 1 second, how far have we traveled? I can't remember. After 1 second, what was the distance? 1 meter? Oh, so it's going to go through 1, 1. It can be 1 over and halfway up a square. Yes? After 2 seconds, how far had we traveled? 4. So 2, we'd be 2 squares up. 1, 2, 4. Now, by the way, since there are numbers, I'm going to be a little fussier in our sketching and graphing. Now all of our graphs should look the same. After 3 meters, how far have we gotten? Oh, so halfway up to the 10. Here's what I want you to notice. A curve. Yes? A curve. Getting steeper. Why, Maddie? Because we're accelerating. Velocity is not constant. I can see from the graph. It's also convincing me that that equation that we derived a few lines ago works, because that also matches what we did last day with graphs. Let's graph velocity versus time. We started out at 0, 0. After 1 second, how fast were we traveling? Oh, and by the way, I think we're going up by ones on the y-axis on this graph, yes? So after 1 second, we were 1 meter, is that right? Yes?
Yeah.
Seems wrong. After 1 second, how fast were we traveling? I didn't say graph average velocity. After 1 second, how fast were we traveling? 2. Knew that seemed wrong to me. Football player. Redeem yourself, Cole. After 2 seconds, not our average speed, how fast are we traveling?
4.
And after 3 seconds, Cole? And do you notice we do get a straight line here? Why do we get a straight line here? Constant acceleration, because the slope is the acceleration. And I think the fact that the graph looks how I expected and confirms what I saw also convinces me that that equation, Greg, that we derived, I think it works. I'm going to ditch the graphs for a while, and I'm going to go with the equation. So we have a velocity equation, Vf equals Vi plus At. We have a distance equation, d equals a half bracket Vi plus Vf times t, although I'll be honest, we don't use that one all that often, especially in physics 12. We have another equation that we call the distance equation. It's on your sheet. It's d equals Vit plus a half At squared. We're going to derive it in just a second. You don't have to know how to derive it, but I'm a nerd. Jacob, I have to show you where it came from. Okay? And here's how we're going to derive the distance equation, as we call it. That's why I wrote here as a heading, the distance equation. By the way, again, we're assuming unchanging acceleration. If you have changing acceleration, this gets way ugly. You need calculus. And it was for something as simple as a changing acceleration that Isaac Newton invented the calculus. It was I got to figure out what's going on here. And he came up with a whole new branch of mathematics to solve it. First of all, we have this. V average equals add them up and divide by 2. Right? So, let's do some algebra. Let's do some deep thinking. Let's turn the page. Distance is defined as average speed times time. As an equation, V average times time. Oh, and I just said, Race, that V average was add them up and divide by 2. Oh, and TJ, not too long ago, about 10 minutes ago, we also said V final was V initial plus AT. Remember that one? So what I'm going to do is I'm going to replace this V final with that, because if V final is VI plus AT, wherever I see V final, I should be able to write VI plus AT. For those of you from your Math 10 days, we're using the system substitution method. I'm going to get this. D equals, instead of VF, I'm going to write VI plus AT, and then there's still a plus another VI. That's all divided by 2 times T. Matt, can you read to me what it says in the brackets, please? VI. Just no, don't even just read it. VI.
VI plus A times T.
No, don't even say times.
Plus AT plus VI.
Okay, start again. Can you read to me what it says in the brackets?
VI plus AT plus VI.
Did he say VI twice? Then instead of writing VI plus VI, can't I gather like terms? Can't I write that as 2VI? Let's do that. I'm going to write it as 2 VIs. There is still, Matt, an AT. It's all divided by 2. And there's a T on the outside there. What's happening between the T and the bracket. If there's nothing written, what mathematical operation does that mean? Multiplication. So I think we can go multiply it in. When we do that, we're going to get this. D equals 2 VIT plus A. I was going to write, what? T squared is nicer than writing TT. And this whole thing is divided by 2. I'm going to do one more thing. Can you see I got a big fraction on the top divided by 2? I'm going to split that fraction right down the middle. If I'm only dividing by one thing, like a 2, I can, instead of writing everything divided by 2, I can rewrite this as the first term divided by 2 plus the second term divided by 2. I can break it up. I can. Now, why did I do that? Look at that first term. How many 2's do you see on the top? How many 2's on the bottom? 1. You know what? They cancel. And I get VIT plus, who remembers, because I hinted at this earlier, dividing by 2 is the same as multiplying by what? Or as a fraction? A half AT squared. This is our new equation. D equals VIT plus a half AT squared. And everything that is a vector, everything but time, can be a vector. This works for both vector and scalar. This is one of the big equations. I said that you would probably end up memorizing 2 equations in this unit. The one that you'll memorize is this one, because you get tired of looking it up. D equals VIT plus a half AT squared. And the VF equals VI plus AT. The other ones you'll probably still look up. Some of you may memorize all 4 just because you use them so often. Oh, is that on your formula sheet?
Yep.
Okay, see where it is? Who's in grade 12 here? No one is. You're in grade 12?
Yeah.
Okay. Did you do, no, you and I talked already. I was going to, if I say what's a quadratic equation, does that ring a bell with you? No. Okay. Who's in pre-calc 11 here?
Me.
Who's in foundations 11? Okay. You're going to learn later this year, Nick, and later this year, all of you, an equation that has a squared in it, like this one. It's a quadratic. You're going to learn something in Math 11 called the quadratic formula. You're going to learn how to factor to solve quadratic. Quadratic equations open up an entirely new approach to having to solve equations. And when you're doing math and you want to, or someone else in your class says, hey, what's the point? Why? You'll have a good answer. You'll say, oh, in physics we use this thing all the time. And Mr. Duick has to avoid certain questions in Physics 11, and it drives him crazy because in Physics 11 he has to assume we don't know how to solve a quadratic yet. He can in grade 12, but I have to give you really watered down questions. I got to avoid some cool ones. Frustrating. Lastly, oh, again, TJ, I showed you where this equation came from. Am I going to ask you to reproduce this? No, but I think it's nerdily cool to show you where it came from. The last one, it's a yuckier derivation. I'm not going to bother. Here is our 4th equation. It goes like this. VF squared equals VI squared plus 2AD. This one is very easy to derive. It comes out of kinetic energy. So we'll derive this one in about 3 months very easily. For now, I'm going to say, Chris, and I don't do this very often, but I'm going to say, trust me. Trust me. It works. Is that also on your formula sheet? There's the big 4. These are the big 4 uniform acceleration equations. And from this, you'd be stunned at what you can solve. Oh, and if, Jacob, I gave you the calculus versions of this that can deal with changing accelerations, then you can solve almost any situation on the planet that moves. This is much of the math that they sent people to the moon with. Well, we have to work in some forces and some gravitation. but it started here. Let's do some examples. To solve a problem, remember I gave you the acronym DFIC. What did the D stand for? Do you remember? Someone said it back there. Thought it was Nick. No? No. What did the D stand for? I gave you this acronym, did I not? I think I did. Yeah. What did the D stand for? List your data. Okay? This is why, today is why, and for the next 2 days is why I gave this acronym. F stands for find a formula. I stands for insert, and C stands for crunch the numbers, or calculator. You ready? Example 2, an object starts at rest. That's an important word, at rest. Let's underline that. Travels 12 meters over the next 3 seconds while accelerating constantly. Find A, the acceleration. Let's DFIC. Let's list our data. At rest, what does that tell me? And don't say velocity. I need more specific. Which velocity?
Initial.
Is what?
0.
Yes. Yeah. Okay, so you ready? At rest, what does that tell me? Say VI is 0. VI is 0. Let's write that down. I've listed some data. Oh, and Kelly, I've written something down. My question is no longer blank. I'm less nervous. I feel better. Let's keep going. I see a 12. See it? What's that? How can you tell without having to think too hard? Have you been clever enough to memorize certain units already and what goes with what? Because that's a great, great, great thing to do. By the way, it could be a displacement. The nice thing is the equation will take care of it for me, as long as I'm careful. I see a 3. Time. I don't see any other numbers. What do they want me to find in part A, Abraham? So I'm going to go A bracket, A equals question mark. Now, here's the key. I'm looking for an equation of those 4. And that equation has to have V initial, D, T, and A in it, and nothing else. In other words, don't you dare read me one that has V final, because I don't know V final. Which equation has V initial, D, T, and A in it? And don't say equation number, read it to me. Yes, Cole? Don't read velocity, just read me the letters. We're even going to go shorter. D equals VIT plus a half AT squared. We're going to say it that way. I totally agree with you, Cole. Let's write it down. On a test, I would make this question worth 2 marks. You would get 1 mark for writing the equation down, because I think that's the most important step. Or if it was worth 1 mark, I'd give you a half mark for writing the equation down. The message is, Jordan, don't you dare leave questions blank on this test. I'm going to expect and assume everybody, if they can't DFIC, they can at least diff. You can get the D and the F part, I think. Oh, look at my values. Are any of them 0? Because this is kind of nice. Which one is 0? Yeah, we got to be fussy. Eventually, we're going to have several initials kicking around in different things. So I'm going to be, what's 0? Initial velocity. I'm going to make a little note here. I'll do it in red. This equals 0. Now, why is that so nice? What's 0 times 5? What's 0 times 10? What's 0 times t? This equation becomes even simpler. That won't happen all the time, but zeros are nice. It'll happen often if there's zeros. When will we have zeros? If you're starting out at rest, your initial velocity will be 0. If you're coming to a stop, your final velocity will be. Or if you're starting on the ground, your initial distance will be. How high will you be? So they show up quite often. Keep an eye out for them. So my new equation looks like this. AT squared. And you know what? Instead of multiplying by a half, I'm going to divide by 2. I have a reason for that. Same thing. And I want you to get great comfortable moving from dividing by 2, timesing by a half. They're the same thing, whichever one is more convenient. Abraham, you identified this for us. What are we trying to find? No, you told us what we're trying to find. What are we trying to find? Acceleration. Which letter is that in my equation? Let's get the A by itself. Look, 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 look. I see a t squared. See it, see it, see it, see it, see it? What's the t squared doing to the a mathematically? Timesing. So how would I move the t squared over? So if I hear you correctly, you're saying my new equation, this is why you don't try and memorize all of the possible equations. You learn to rewrite them. There's going to be a d, and that d is going to be divided by a t squared, because you said to move the t squared over, I divide. I agree with you, Cole. What else do you see sitting on the same side as the a? It's meant to be really obvious, boys and girls. What else do you see sitting on the same side as the a? Not distance, that's on the other side. What else do you see? Huh? Dividing by 2. See it? See it? See it? See it? See it? How would I move the 2 over? What's the opposite of dividing by 2? Are you telling me that if I do that, I've moved the t squared over? Yes. Check. I've moved the 2 over? Yes. Check. Is the a now by itself? The only thing I'm going to do, I'm going to put the a on the left side because we're used to having the thing by itself over on the left. You could write equals a. There's nothing wrong with that. We've got yet another equation that's not on your formula sheet. I'm not going to memorize that one. I'm going to say I'm going to get good at being able to rewrite these on the fly. In fact, in about 2 weeks, when I say what equation are we going to use, many of you will actually read this, read that, and you'll verbally tell me this right away, doing all of the rest of that in your head. And Nick, I think that's great. Oh, and if you get good at that, that's a huge time saver on a test. I figure I can save you on an hour-long test about 15 minutes. Is that worth it? Yeah. Also, my argument, Aaron, is we make less dumb mistakes with letters than we do with numbers. We do. We've done D. Check. We've done F. Check. What's the letter I stand for? Let's stick in the numbers. This is going to be equal to what's D? 12. Nick, do you see what I mean now? It's kind of a joke, but you see, it is plug and chug now. It really is plug in the numbers and then go chugging away on your calculator because, Nick, what's T? I listed it. What is it? As a number, as a what am I going to write right now? And don't forget the squared. It's 2 times 12 divided by 9, if I really... Good. What is it? Go to your calculator. 24 over 9. It's going to be the same as 8 over 3. It's going to be 2.66666666. Yeah? How many sig figs am I going to go to here? Look at my data. How many sig figs are showing up in my data? Look at my original data that they gave me in the question. How many sig figs did they give me in every single bit of data in the question? 3. Yes? 12.0. 1, 2, 0. 3. 3.00. 1, 2, 3. So how many sig figs am I answering? Let's go to 3. 2.6 what? 7 units. Meters per second squared. B. Enzo, what do they want me to find in B? Hey, what was that in our symbols? How do we write that? I'll give you a hint. It involves a V. Yes. VF equals question mark. Now, I'm looking for an equation that has VF, VI, D, and T. It can have A if I need to, but I would prefer not to use A because if I use one that has an acceleration in it, if I got A wrong, what does that guarantee about B? I'm going to get it wrong. If I have to, I will, and there will be some times when you have no choice. But I think there is an equation that has D, VI, VF, and T in it, and no A. Which one? And you know what? I prefer that form right there. Same equation. Ooh. Are any of these 0? By the way, when I do this, it's also because I want you to talk loud enough that my recording picks it up so when kids are watching online. Go ahead. VI. Woohoo. And also, I think if you know the answer, be authoritative. VI. Echo. Right? Okay. What are we trying to find, Enzo?
Final velocity.
VF?
Yes.
Let's get it by itself. What do you see? We're dividing by 2. See it? That's why instead of a 1/2, I made it a divided by 2. How would I move the 2 over then, do you think?
Times 2.
So I think there's going to be a 2d. Yes, 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 yes.
2D.
Oh, and I see a t sitting outside the bracket. What's that t doing?
Multiply.
How would I move it over?
Divide.
What's left inside the bracket? Technically a VI plus VF, but what was VI, Aaron? So you know what? I think we have the VF by itself. Oh, you know what? I like writing the by itself over on the left-hand side because that's what we're used to. There's a brand new equation. Am I going to bother memorizing that? No! I got the 4 on my sheet. I can derive whatever I need to. I'm good. Let's plug and chug. It's going to be 2 times 12 divided by 3. Holy smokes, I don't even need a calculator. 2 times 12 is 24. Put it down, Enzo. Divided by 3. 24 divided by 3, Enzo, is what?
8.
Woohoo! Why is 8 wrong?
Oh, wait.
Why is 8 wrong? Units. Okay, let's put that. What are we, meters per second? Why is 8 meters per second wrong? Right? I'm not going to take marks off, I told you. I'm just going to be fussy. I'm going to nag. Okay. Turn the page. Let's try another one. DFIC. DFIC. A dolphin accelerates. Oh, dolphins. Oh, Flipper. You guys don't remember the show Flipper, do you? I grew up on that one. When I was a little kid, Flipper was a show about a kid who owned a dolphin. So every kid my age wanted to be like a dolphin trainer. A dolphin accelerates from 1 meter per second to 7 meters per second in 5.5 seconds. By the way, just by reading that and knowing your units, can you see you've got a lot of data that you can list already? Yes? Well, let's start listing. I haven't even looked at what they're asking me. Well, I should. What are they asking me to find in part A, Kelly? Okay, let's list our data. I usually list it on the left-hand side. I see a 1.0. What's that?
Initial velocity.
VI is 1. I see a 7.6. What's that? VF 7.6. I see a 5.5. What's that? Part A, they want me to find acceleration, Kelly said. So I'm looking for an equation that has VI, VF, T, and A in it. Oh, and no D. Okay, Abraham, I don't mind you looking at the white sheet because they're all there. The reason I want you to get used to the yellow sheet is I want you to train your eyes what row to glance in. They are all about 1/3 of the way down in a single row there. Yes, yes, yes? You got other stuff. I don't really think you need much of that other stuff ahead of, but it's also, I gave you some extra stuff that I think it's worth having here, but I wimped out and gave you the extra stuff. You got the row? Yeah. Okay. Aaron, are any of these 0?
No.
Then let's get the A by itself. Are you ready? Eventually, I'm going to divide by T. You know how I know? Because there's a T multiplying onto the A. But when you were equation solving, you did your division thing last. I got a VI. How will I move the VI over? What's the VI doing to the AT? Adding. What's the opposite of adding? So if I hear you correctly, I think you're saying it's going to be VF minus VI? Yes? And then how would I get the A by itself? How would I move the T over?
Divide by T.
In fact, this is the acceleration equation I gave you a couple of lessons ago. I'm never going to rederive that equation for you anymore. I start that way because acceleration is a tricky concept, but it's hidden in the VF equals VI plus AT. And again, in fact, probably by the end of next week, if I do my job right, Kieran, if I say what equation, you won't actually say to me VF equals VI plus AT. You'll glance at your sheet, your eyes will go glazed for a split second, you'll rearrange it in your head, and you say, oh, do it, it's VF minus VI over T. You'll read it, you'll do all of the algebra in your head, and I'll smile, and my little math nerd heart will go pitter-pat. Have we data? Yes. Have we F formula? Yes. Insert. Okay. VF 7.6 minus VI 1 divided by T 5.5. Is there more than one number in the top of this fraction? Yeah? Better go brackets. If you're silly enough to do this, that's wrong. Your calculator does not know that you want it to divide the 7.6. It's only going to divide the -1. That's bad. It's 7.6 minus 1 divided by 5.5. You get, oh, 1.2 even? How many sig figs? Check your data. 2. So 1.2 works for me. Units? Meters per second squared. B. Janai, what do they want me to find in B? Okay, I'm looking for an equation. It has to have D in it, because they're asking me to find distance. And I'd prefer one that has VI, VF, and T. I'd prefer one that doesn't have an A in it. Oh, is the D by itself already in that equation, too?
Yeah.
Oh, nice. That's even easy. That, great. I don't have to rearrange it. Read it to me, my child. D equals?
1 times VI plus VF times T.
That one?
Yeah.
Okay. So here, we can go straight to plug and chug. D equals 0.5, 1/2. VI, 1. VF, 7.6 times 5.5. What do you get? How many sig figs should we go to on our answer, though, Nick? No, you're right. How many sig figs should I go with my answer? 2. So 23.65 to 2 sig figs would be 20 what? That to 4 sig figs. Right? Sig fig, that many digits. A 2 is your first digit. And the 3, there's a 6 next, it becomes a 4. Look in brackets. What does it say the answer is? Look at your, I included the answers on these. No, in your notes, look at the notes, look at the question, look down, look down, look down. Look right next to there in brackets. Did I include the answers in brackets? See it there on the right-hand side? Yes? So when you said 23.65 and you said, I think that's wrong, can you see why I said, no, I think you're right? Because what is the answer that I wrote? No?
I can't even see it. Oh, right there. Oh, okay. So,
I gave you the answers. Can you see them?
it has like,
Oh. All right. Amazingly, Nick has just finished his test. He's about to hand it in, and oh, wait a minute, I got 15 minutes. And he says, hey, wait a minute. There is another equation that has a D by itself, too. Yes? What's the other equation that has a D by itself? It's meant to be fairly obvious. There's only 4 to pick from, and there's only one other one that has a D by itself. Nick?
D equals V, T.
Not VT. You missed a letter.
Velocity.
Not velocity. Which V?
VI.
Ah, that's key. That's hugely important. Start over. D equals VIT plus
1/2. 1/2.
1/2 is what I've gone with, actually.
AT squared.
Okay. The reason I chose not to use it was I was worried, Amanda, if my A was wrong. But I got time. Yes, I finished the test. So now what I would do, don't write this down, but I would quickly go D equals VIT plus 1/2 AT squared. I would use the 1, the 5.5 plus 0.5. I would use the A that I found and the 5.5 squared. Try that. What do you get? Type that into your calculator. What do you get? Don't write this down. Type it into your calculator, Cole, instead of spinning the coin. That's circular motion physics 12. What do you get?
24. I know that 1.2.
You haven't done it yet. The rest of you. Type that in. What do you get? Do you not get 23.65 again? Exactly what you got before? Yes? Yes? What does that mean? I now know not only do I have B right, I must have gotten A right because I used the information from A, solved for D using a completely different equation, got the same answer. I know I'm getting perfect on both these. That's kind of nice, and it's a fairly quick check. If you didn't get that, by the way, make sure you included the squared. That's the most common mistake. Okay. We're going to pause here. We're going to practice this more tomorrow. Your first absolutely must be done for tomorrow homework is the take-home quiz, but also, because these are involving graphs, I'm giving you 10 minutes. You can try number 1, number 2, number 3, and number 4. See if you can figure that out. I included the answers on the very back there. Oh, and there's some lovely Calvin and Hobbes comics if you're interested.